Hi, welcome to a video on evaluating improper integrals. I'm going to do a couple of examples. I'm going to start with one example where I use a very formal notation, and in the next example I'll be a little bit more informal. So we're going to take a look at integrals of this form where we go from a constant to infinity. Those are the ones that we have the most applications of here in business calculus. There are a lot of applications of these having to do with area or accumulated present value and other things, but for now we're just going to stick with ones of this form, which, as you can see, our first example here is of that form. Okay, so what we're going to do is we're going to start with this integral and we're going to rewrite it as a limit. We're going to use a letter. B is typically the common letter. We're going to change the integral from 3 to b of 4e to the negative x dx to evaluate it. So when we do this, we're going to start with the antiderivative of our 4e to the negative x. So I put here a reminder of our integration rules. So we're going to apply this rule here. Some videos will do substitutions to do this, and I just don't feel like we need to do that. So here goes. I'm going to go limit as b goes to infinity. I'm going to take my antiderivative of this, which will be 4e to the negative x, and divide that by what the k would be, which is a negative 1. And we're going to keep our limits of integration on here from 3 to b. Okay, and then carrying this on, again I'm going to keep the limit with this until I actually evaluate the limit. So I'm going to rewrite this as negative 4. I'm going to put this e to the negative x down on the bottom so I can make that an e to the positive x. And then we're going to evaluate from 3 to b. Okay, I'm ready to put my limits of integration in, and then I will evaluate the limit. Alright, so this is going to be limit as b goes to infinity. I'm going to plug in my b. I'm going to have negative 4 over e to the b minus negative 4 over e to the third power. Now, letting b go to infinity, so this b right here, if I were to plug in a very large number in for this b, e to that power is going to be a very large number, and therefore when you take a negative 4 and divide it by that huge number, you get 0. So the limit of this first term becomes 0, and then I have a double negative, which is going to make a positive 4 over e cubed. Now notice I dropped the limit because I've evaluated that, and then here's my answer, 4 over e cubed. Now that's the exact value of this improper integral. If you want, you can type it in a calculator and get the approximate decimal, which if you type that in, you're going to get a 0. Something around 1991. So just depending on whether your instructor wants an exact value or an approximation, you can decide. Alright, so that's how we evaluate an improper integral. Now the next one I'm going to do pretty much the same way. I'm just not going to be as formal about my notation. Alright, so on this integral here, let's just start with, I'm just going to leave the infinity on here. And I'm going to start with my antiderivative. So this is going to give me a 6e to the negative 3x divided by this negative 3. And here I'm going to evaluate from 0 to infinity. So the only thing I'm doing different is I'm not putting the limit in there and substituting a letter for the infinity. I'm just going to remember that infinity is really not a number I can plug in, but more of a concept. So when I go to do that, okay, 6 divided by negative 3, that's going to give me a negative 2, and I'm going to do something else. I'm going to take e to the negative 3x and throw it on the bottom so I can make it e to the positive 3x. And then I will be evaluating from 0 to infinity. Okay, so now plugging in 2 over e to the 3, and then I plug in, even though it's not exactly possible, infinity. minus, and then I have a negative, don't forget negative, 2 over e to the 3, and I'm going to plug in 0. Okay, so again, like on the last example, when this on the bottom of the fraction becomes a very large number, negative 2 divided by a very large number, that's just going to become 0. So we end up with 0 there, a double negative, so plus 2 over e to the 0. Now e to the 0 is just 1, so I end up with 2 over 1, so my integral is 2. Now I didn't mention it before, but if you want to go with some terminology, if you have an improper integral and you can find the value of it, we say that that integral converges. If we would not be able to find the value of the integral, we would say it diverges. But on both of these two examples, we were able to find a value, so these are both integrals that converge. Thank you. Hope this has been helpful.